Hello again, students. Fruitport here. So BCA tables. We're going to jump to number 5 and see how you like this. This is shows how you can do 2 questions in one problem using the same BCA table. I call this level 2 problem. So if you want to flip to number 5 to follow along, you can kind of see this here. So number 5, I'll read the question. Iron, metal, and oxygen combine to form magnetic oxide of iron, Fe3O4. How many moles of iron can be converted to magnetite by 8.8 moles of pure oxygen? How many moles of iron oxide would be produced? So as I read this question, I think that we have this given to us as a starting fact. But when we read through this, there are actually 2 questions. How many moles of iron can be converted? And how many moles of iron oxide would be produced? So we're going to have to solve for 2 things, but we'll just use one BCA table to do this. Okay, so let's come up with the equation. Iron metal is just Fe, and oxygen, so don't forget that's one of the diatomics, and they gave us Fe3O4 as a symbol for this iron oxide called magnetic oxide of iron. Maybe it's called magnetite. And so to do this, it looks like I got 4 oxygens and 2 oxygens, so I should double that to 4. I have 3 irons and 1 iron, so I'll put a 3. So we got a 3 to 2 to 1 ratio. So I know my change column will be a 3 to 2 to 1 ratio as we work with this. Okay, so to use the pink marker again, it looks to me like they're giving us 8.8 moles of pure oxygen. And one of the questions they asked for is how many moles of iron can be converted? That means we want to know how many moles of iron we would have started with. And the second question, how many moles of iron oxide would be produced? So we're going to put another yellow box showing that this is our goal. We want to fill that out there. The other thing is that we could assume that we have 0 moles of these materials, and in an ideal world, we use all of the iron and all of the oxygen up. Okay, so I would argue that after reading this question, we've done a lot already, but this is just taking information from up here and putting it into the start of the BCA table. It is now time to fill in the rest of the BCA table. Okay, so when I get to this point, I'm always looking for the columns. Which column can I fill in first? I need to know 2 of the 3, and it looks like it's the oxygen column. I know the before, I know the after, but I don't know the change. And I can figure out the change because, again, before plus change has to equal 0. So this is going to be negative 8.8. So this plus this equals 0. Okay, now that I have one of the changes, I can do all the changes, but I have to remember that the changes are going to be the same ratio as the balanced equation. The before moles are not 3 to 2 to 1 ratio. The after moles are not going to be a 3 to 2 to 1 ratio. The whole point of balancing is so we can get this C column, the change of moles. Well, I'm pretty good at math in my head. You might need a calculator, but I know that this number 1 is half this number 2. So whatever I put in this box has to be half of this number. And 8.8 cut in half is 4.4. But I'm going to emphasize that we're creating this by putting a positive because the Fe3O4 is getting bigger. And now that I have 2 columns, I can say 0 or 2 squares in the column. I can say 0 plus 4.4 is 4.4. It looks like I've already answered one of the questions. How many moles of iron oxide would be produced? 4.4 moles of iron oxide. All right, now I still got to work over here. Now this is a 3 and this is a 2, so you could do a 2 to 3 ratio, but I'm actually going to do a 1 to 3 ratio because I like dealing with ratios with ones. So I know this number is going to be triple this number. It'd also be 1.5 times bigger than this number if I wanted to, but I'm just going to take this and take the 4.4 and multiply by 3. I get 13.2. And so I'm going to put in 13.2. And then remember that it's not a positive, it's a negative, because anything on this side of the arrow will have negative changes. And what minus 13.2 equals 0, or what plus negative 13.2 means this? 13.2. So I could answer the question. Maybe at the bottom I could write like, hey, I would need 13.2 moles of oxygen, and I would produce 4.4 moles of iron 3 oxide. One way to make this question harder is, what if I change this word moles to grams? That's coming up, you guys. How do I change this? Well, I still have to do the BCA table in moles. All these numbers, all 9 of these numbers are moles, but I could take this answer and convert it to grams by using our lesson from last week where we did mole conversions. I like to use the mole roadmap. I might have to look up some molar mass and use a calculator, but that's coming up next time. All right, I hope this is helping.